डियर स्टूडेंट, सब्सक्राइब बटन और बेल बटन को दबाएं ताकि मेरे वीडियोस आपको सबसे पहले मिल सकें।
Bismillahirrahmanirrahim. My dear students, let's today discuss the topic vector and we will learn its subconcepts. Here is a list of two types of concepts under this topic vectors. One is column vectors and second part is general form of vectors. In your column vectors, we have representation of vector in the beginning, then negative of a vector, magnitude of a vector, equal vectors, addition and subtraction of vectors including scalar multiplication, and parallel vectors. And in general form, finding a vector in the sense of a resultant vector. Basically, we need to find vector. हमें vector ही find करना होता है, but that's in the form of a resultant vector. Then use of ratio that's given in the question. With the help of that, again our focus is to find the vector, and then finding numerical value of the ratio of vectors, and then the ratio of areas of triangles, a very key and very typical portion of this whole topic. And then finally, position vector is a mix-up of both concepts with additional sense of coordinates used for vectors. So we will now learn in detail all these concepts related to vectors. If you want to prepare for exam, a real preparation, you want to strengthen your topic, you need to remember sub-concepts included in the topic vectors. So now we will separately discuss in detail and try to understand with the help of examples and the techniques used while solving and finding all the things present in these sub-concepts. Let's see first of all representation. Alright, my dear students, let's learn representation of vector. Representation of vector has the concept in a sense. For example, if we have a vector here, this is a line and its direction. That's constitute a vector. A line, that's the magnitude part, and its direction, that's constituting a vector. If in the topic of vectors are represented by capital alphabets, they are representing from the vertices, the starting point and the ending point, like these 2 points A and B. And we write it as this is vector AB or AB vector. If a vector is represented from the middle somewhere, and this is always represented by small English alphabet, and there is dash below this one, that indicate that this is a vector A, or this is a vector represented by small English alphabet. Alright, and the third sense representation of vector is in the form of column vector. For example, we have this vector AB, and this is in the form of a column vector X and Y. So the representation of vector, when the vector is represented by capital English alphabets, that is all the time represented from the coordinates, endpoints or vertices. But there is possibility a vector is represented in the middle, then there will be a small English alphabet. हम capital English alphabet use करते हैं जब endpoints use करते हैं, that might be in a composite figure, vertices होती हैं, so वहाँ पर उनको capital English alphabet से represent करते हैं. But if we have a vector and that is represented in the middle of that one and labeled here, and this is always represented by a small English alphabet. And the third sense of representation is a vector AB is equal to column vectors sense, that X and Y. And these X, Y came from the concept of ordered pair. This is X, Y. They are behaving whenever there is a need of utilizing this on some grid or some graph. So they will behave like ordered pair XY. First is X component and second is y component. And the next thing is the representation of this portion of vector. For example, this AB in the form of digits may be like it's a vector 2 and 3, or there is a vector small a that's in the form of that's -4, -3. There are some examples of column vectors. And the next sentence is, how can we draw these vectors on a square unit graph? Or the reverse is also may exist, that there is already a vector drawn given in a unit square graph and we are supposed to write the column vector. Let's see what will be the situation if we are supposed to represent these two vectors, these vectors, column vectors, on a square unit graph. And if already vector is given there, and how can we write their column vector? Let's see how to. Alright, my dear students, here is the unit square graph. Let's try to learn how can we draw a column vector or a unit square graph. For example, we have vector AB and this is vector AB and its value is 2, 3. And let's another example. This is vector A. This is, alright, my dear students, let's have representation of column vectors on this unit square graph. You might have seen this type of graph already in your early classes math notebooks. Let's consider vector A and we will see how to present on this unit square graph. This is 2 and 3 components of this column vector. How to present this vector on a grid, or this grid, is that we will start this vector from point A. This point will be considered here as an origin, and then both components, this is, as I told you, like order pair form. First value of this column vector is presenting x coordinate, and the second value is considered as a y component in this column vector. It will behave like x and y coordinates on this unit square graph. The point from where we will start this vector will be considered as the origin, and then if we move towards the right with the help of these units components, that will be positive value. If the value is negative, then we move towards the negative side, left side of origin, that will be presentation of values of x. If value of y is positive, from that place we will move from origin upward. If value could be नेगेटिव तो हम उसको नीचे वाली साइड पे ओरिजिन से काउंट करेंगे और लेबल करेंगे. So my dear students, let's see how to present this one. This starting from where? We can start from anywhere. Present this vector on the unit square graph. The point, as I earlier explained, A would be considered as an origin. We will try to start. We can draw at anywhere on this unit square graph, but we need to keep in mind that this should not go beyond this existing given unit square graph. So we will try to draw from a point where it can be adjusted according to given units. Let's start with this vector from here, and we will see if this is starting point and if this is point A, then how many units along x-axis? This is 2 units. This is 1 and 2 units. And positive value of y is 3, 1, 2 and 3 units. This is finally the destination of this vector, that is point B. We will join these two vectors, and here is the direction. So our vector in column vector form, that is 2, 3, when we are going to present on square unit graph starting from A, and with the help of this component we have drawn its endpoint. And now this is the vector presented on unit scale graph. Let's have one more example. We have vector A, and this is -3 and -4. For example, now again, we can start from anywhere, but it must be feasible, that it must be workable on this present graph. So because both are negative, we will try to start from a little left side so that we can have their existence. Let's suppose that this is the starting point of this vector A. From here, the value of x is -3. This is 1, 2, and 3. And value of y is -4. This is 1, 2, 3, and 4. Here is the final destination of this vector A. The point from where we will start will behave like origin, and then according to this thinking that this is origin, then we will apply these points. And now let's draw this vector. This is the vector that is presented as vector A. It was given us, and we have drawn on this unit scale graph. And this is the way you can number of vectors you can present of this, but this is the method and technique how to draw a given vector on a great unit scale graph. And there is a second sense involved in this topic, is there might be already given vector that is already drawn. For example, examiner has already drawn a vector. Let's see, this is the vector that is already drawn, and this vector is Q, and this is P. For example, this vector, and this vector. This vector is B. Let's say we have given these two vectors, these are already drawn. The question is, if PQ is a vector on this unit scale graph, write its column vector. And similarly, if B is a vector here on this unit scale graph, write its column vector. As I told you, the starting point of vector is considered to be origin. Then according to this situation, we will count how many units we are moving towards left or right. If we are moving towards right, it depends how many units we are supposed to move towards right side or left side of this origin. From this you can see we are moving towards right side. We'll count how many units we move, and then how many units we are moving up or down. If it will be up, positive value of y, down is will negative. This is 1, 2, 3, 4, 5, and 6 units along x-axis, 1 and 2 along y-axis. So my dear, the vector PQ is 6 units towards right, 1, 2, 3, 4, 5, 6, and 2 units down is a minus sign with y component, and our vector is PQ, and this is 6 and -2. And let's see the second vector B. Its starting point is here. As I told you, this is origin. Now we will count how many units we are supposed to move along x-axis. Now this is 1, 2, 3, and 4 units, and then 1, 2, 3, and 4 units. In both axes, the vector B is equal to, this is 4 and 4. So my dear students, these are two concepts related to representation of column vector on a unit scale graph. If the vectors are given, this is the way how to draw them and label them. And if the vectors are already drawn on the unit scale graph or on any grid that's in the form of graph, then we are supposed to write their column vectors like vector PQ and vector B. And I'm sure you have done it, you got this concept, and if you get little practice more, it will be comfortable for you to attempt any question in any exam. Dear student, this next concept here, we have negative of a vector. We know vector is a constitution, is a combination of two things. One is length and then its direction. If we have vector AB and it's mean there is a certain vector that consists of its this length as well as and its direction. Length and its direction. When we say that what is a negative of a vector mean, that is reciprocal of this vector. Reciprocalism in opposite direction. If its direction is this towards right, its direction would be towards the left, depending on the situation. If we need vector AB, here is vector AB in the I presented in the form of a length and its arrow. There might be vector AB in the form column vector. This is 3 and minus 2. What is a negative vector? It's reciprocal, the opposite direction. That means BA vector. BA vector is entirely opposite vector to vector AB. But the question is, if we have definite value of AB already, then how can we write this? What is the process? The process is, we're supposed to multiply the vector AB with a negative sign if we want to write its reciprocal. What is opposite vector? That's the negative vector. We will write the negative sign with both sides of this vector. This will make the original vector AB in the form of its negative vector. When this negative applied, it will become BA. Why it is so? If this vector is from A to B, when its direction will opposite, then vectors start from B to A. So here, this negative converts this situation that replace their places, change their places, and they'll become B to A. Now vector is moving from B to A because it's the negative of this vector, and this negative we will multiply inside this vector, and we will get here, this is minus 3 and this is plus 2. Now this vector is the negative vector of vector AB. The sense is, whenever you need any vector opposite to the original vector, what we need to do is, we will replace their places, and there's a negative sign involved in the vector that change the sign of the existing components of the vector and make it a negative vector. This will be the part of coming up topics where we need certainly not AB, but we need from B to A, then we will multiply with a negative sign to make it opposite vector. That is called negative of a vector, my dear students. Alright, my dear students, let's see the next concept, magnitude of a vector. As I was explaining, that a vector consists of two things. Vector AB we write in the form of column vector 5, 3. But this vector actually is a composition of two things. That is the length from here till here and its direction, indicating towards this direction. When we say its magnitude, so it means we are talking about its length. What is the length of this vector? If the vector is given in the form of column vector, how can we find its length? This is a topic here. Then, in general form, AB vector is represented by xy, as I told you that this general form xy coordinates actually representing the column vector here in our this topic vector. And if we want to find its magnitude is defined as, here is the magnitude with these lines. They are absolute value in real numbers, in numbers topic, but here it's behaving and symbolizing magnitude of the vector. And this will be equal to, this is x square plus y square and square root. So this formula will help us all the time. Whenever we need to find magnitude of any vector, we will put component of x and y in this formula and we will get magnitude of the vector. Let's try it. For this AB vector, magnitude would be AB vector. Let's write it again. The vector is, suppose we have right now 5 and 3. Then its magnitude would be, therefore, AB magnitude would be equal to, this is 5 square plus 3 square square root. And this will become 25 plus 9. And this is equal to square root of 34. Well, definitely if you will get in a situation where you are allowed calculator, you will get this square root. But in a situation, in a paper where the calculator is not allowed, you will have a perfect square number, obviously. But so in this case, we are concentrating on the magnitude. How to find this length? The square root of this will give you the exact value. Here, if I write by myself, this is approximately 5.9. Approximately 5.9 is the value for this square root. That is the length of the vector AB. Similarly, we can have many examples. Let's consider one more example here. This is example number 2. And that is, a vector A is given and the vector is 5 and 12. Another question is, find A magnitude. Solution is that A magnitude will be equal to, this is square root of x square plus y square. This is formula that we have learned. Let's substitute their values. 5 square plus 12 square. This is square root here. And now this will become 25 plus 144 whole square root. And this is equal to square root of 169. And square root of 169 is 13 units. So the magnitude of the vector A, through this formula we got 13 units. So my dear students, this is basic method, formula and technique to find magnitude of any vector. Now let's move towards little next step question and under the magnitude of a vector. If 10 is the magnitude of the vector, ten is the magnitude of the vector, vector B, then find M. clearly we need to understand what is given in the question. हम क्वेश्चन को अच्छी तरह अंडरस्टैंड कर लेते हैं. क्वेश्चन क्या है कि हमें इस वेक्टर में m नजर आ रहा है और इस वेक्टर का मैग्नीट्यूड दिया हुआ है और क्वेश्चन है कि हमें इस m की वैल्यू फाइंड करनी है. टू फाइंड इट्स वैल्यू we will proceed in the same way as we did in previous examples, that we will write magnitude of vector b in the form of this formula. Here is the formula, and implies that this magnitude in this vector will be m square plus 4 square square root. And now in place of b we will use value given. This is 10 magnitude already given, and this is m square plus 16. Now because we want to find m here, we will eliminate square root by taking square on both sides, and this will be like 10 square, and this is equal to m square plus 16 whole square. This is a square root and this is whole square. So now 10 square is 100, and this is equal to this square root cancel with this square, and we have m square plus 16. Now let's further simplify. Transfer this 16 to this side. This is 100 minus 16 is equal to m square, and this will be 84 is equal to m square. And now we want to find m. So to eliminate this square, we will take square root on both sides, and we will have m square square root. This is m square equals 84 square root. And as we know that when we operate square root on both sides in an equation, quadratic equation, then we are supposed to write plus minus sign here. This is essential. So this square cancel with the square root, and we got m here, and this is equal to plus minus. Again, this is a number that required calculator to be calculated, operated to get its value. Otherwise, this value would be estimated value. So you will be in a paper where calculator is allowed. Yes, take square root with the help of calculator, then write your answer. This is 9.23, approximately 9 point something, but I will take it remain as it is. I will put in the same situation because the answer would be according to the calculator given. This is our value of m when it is given in the vector. So this is a sort of application of magnitude of a vector when the magnitude is given and we are supposed to find the value of unknown. Alright, let's move with one more upgraded step of the application of magnitude of vector. Alright, my dear student, let's have one more example related to magnitude of vector. This is example number 4, and the situation is we have given two vectors AB and CD. AB with coordinates minus 4, 2, and CD with coordinates PL minus 12. The condition is given if CD magnitude of the vector CD is equal to 3 into magnitude of the vector AB, then find the value of this unknown that's present in the vector CD. We will pick this statement and carry on the process of the magnitude of the vector. Here is the solution. We will write this statement as it is. This is CD vector. It's the magnitude we are going to deal with, and this is equal to 3 into magnitude of vector AB here, and this magnitude is here. Yes. Okay. CD, here is the CD vector. We will apply formula, that is x square plus y square. We know already equal to the magnitude of any vector, and we'll carry on this statement. All right, here this is CD. This will be P square plus minus 12 square, and this is square root, and this will be equal to 3 as it is. And then let's move towards AB. Here is AB. This is minus 4 square plus 2 square. Here is the square root. Let's simplify as much as possible. This is P square plus 144 here with the square root, and here 3, and this will be 16 plus 4, and this will be P square plus 44 here as it is, but here we can add them, and this will become 3 under the square root. Here is 20. Now we see that there is radical sign. It's a square root on both sides. We will eliminate first, and then we will carry on our further calculations. Let's taking square on both sides. This is P square plus 144 square root. Let's square on this side, and this is equal to 3. This is square root of 20, and let's square on this side as well. This is cancelled with this one, and this is P square plus 144, and this is equal to 9 into this. When this 2 operated on 3, this will become 9, and when this is operated on this cancel with the square root. We got 20 here. Let's further simplify. This is P square plus 144. This is equal to 180. 9 times 0, 0. 92 is 18. Now we transfer this 144 to other side. This is P square is equal to 180 minus 144. And when we subtract it, this is P square is equal to, we got 36, I suppose. Yes. Subtracting 4 from 10 will give you 6. And subtracting, we have remaining 7. And subtracting 4 from 7, we have 3. And 1 from 1 is 0. So we got here 36. So now we want to find P. We have square value, so we will take square root on both sides. This is P square with square root is equal to plus minus sign with 36. As it was mentioned in the question, we are supposed to find the positive value of P. So therefore, these 2 cancel with square root, and P has a value 6. We won't write negative here because we only need a positive value. So the value of P is 6 in this situation. My dear students, these are last 2 examples were the application of magnitude of a vector. This sort of questions are handled with the use of basic formula that is related to magnitude of a vector. We plug in the values of components of any vector, and then carry on calculation. That might be to find directly magnitude, or with the help of magnitude we might be need to find some unknown values. Now this is all about magnitude and its application, and I hope you have learned a little, improve this with a little more practice, or you can revise this while watching this video. Revise these examples 1, 2, 3 times, and I assure you that you will have very good command on this concept, finding magnitude and the use of magnitude in the problems of vectors.